Good morning, Mr. C. This is the Math 1113 Zoom meeting, first Zoom meeting of the week of 119 to 122. Hope you all had a good MLK holiday yesterday. Got the notice of it out pretty late last night because I was out of town all day yesterday to get back till late. We are going over sections 4.3 and 4.4 this week. In section 4.3, practice problems are 25 to 47 odd. Section 4.4, the page 395, practice problems are 9 to 57 odd. Going to keep the same format for the entire class. Not taken up for a grade, but we have quiz 2 on Friday 122, due Sunday 124, will be based on them. Web assigned problems for this week. Again, they're on the personal study plan. Find your way to chapter 4. Section 4.3, problems 3, 4, 5, 6, and 8 only. 4.4, 1, 2, 3, and 4 only. And just email me the percent of these 9 problems, should be 9 problems that you get correct. Get them all, 9 out of 9, 100. 8 out of 9, whatever that works out. Okay, we'll do 4.5 next week, and we'll have the test next week. There won't be a quiz next week, just a test over chapter 5. Okay, why don't we charge in on some of these practice problems? Start working some of them. Should be a review from college algebra if you took college algebra. 4.3. Problems 25 through 47. They are these right here. Just picked out 3 sections. No, I don't think there's any point reviewing the whole thing. Just these 3 sections. Through 47, 25. Through 47 there. So there's 3 sections here. We'll work a couple out of each section just for examples. So we'll start with 25. Part A. We're supposed to evaluate the expression and it's a log base 2 of 2. All right, well, without a whole lot of lecture or anything, I hope everybody knows that if you go, log base 2 is not on the calculator. So what is an ln, and ln and e undo each other. So if I go ln e to the 2, I should get 2. And you can actually check that on the calculator. ln, I punch the ln key here. And then functions that undo each other are on the same key. So if I hit second ln, and I messed it up, let's start over. So ln, and I hit second ln, which is e, raised to the 2, and I get 2. And you can punch the keys, so I'll do it over here. ln e to the 2 is equal to 2 because these undo each other. E to an ln of 2, hope you believe me if I don't punch it, is also 2. That's punching the keys in reverse order, these things each other. On the calculator, you get base C and ln, and you get base 10 and log. So log is base 10 of 10 to the 2 would be 2. And 10 to an log of 2 would also be 2. And you can punch these on the calculator. So yeah, you can punch these on the calculator. Log, you can either punch literally 10, or you can hit, it'll work either way, or you can hit second log the calculator version of 10 raised to the 2, and you get 2. All right, so I hope that's enough to convince you that when you go to any other base number, they show the base it undoes here, then the base of the exponent. And so you are going to get 1 out of this because 1 is the exponent. Understood, and they don't have to write 1. As if these undo each other. All right, this should be a review of college algebra. I hope everybody remembers this. You can go down, 26a is pretty similar. Log base 3 of 3 to a 7 power, of course, would be 7. All right, some of them have a few more steps. If you do 26ab, log base 4 of 64. Okay, well, the idea is you've got to rewrite to look like this. Well, hope you know that a log base 4, 64 is 4 to a 3rd power. You would get 3. As these undo each other. Okay. Some of them got a few more steps in them. 34a, part A, log base 4 of the square root of 2. All right, so this is a little trickier. Square root's in a half power of 2 to a half power, and these do not directly match. Do not match. But you can write 4, or 2, I'm sorry, as the square root of 4 again, meaning log base 4 of the square root of 4. Again, that's raised to a half power. This is your 2. Well, that 4 is raised to a half power. So that's a log base 4 of 4 power raised to a half power. Well, when these raise, they multiply, and that would give you log base 4 of 4 to a 4th power. That would give you 1/4. Okay, there's a few of you, those in there for you to practice. And again, we will have a quiz on Friday over these kind of problems. When you go to problem 35, they're giving you an x in a problem, and they want you to find your x. If we try, say, 35a, this is still off page 388. Part A, they want you to find x. And they give you a log base 4 of n x is equal to 3. Right. And so what you do is you undo. Take a base of 4. 4 to a log base 4 of x, so base 4 raised to this same power. You got to do whatever you do to one side, you got to do the other side, so the other side becomes 4 to a 3rd. These undo each other. That leaves the x and 4 to a 3rd power, 64. Okay, and in fact, this is exactly right up here. If you look back at 26b, you can see they work it in this version in 26b. And we got 3. So they gave you the equation up here, and we froze. Okay, Wi-Fi freezes on occasion. And so we're back. I don't know how long for it to freeze again. Work a few more examples here. We can try maybe a tougher one like 35b. Find x again. Log base 10.01 equals x. You can actually punch this on the calculator, and they usually don't tell you it's a base 10 when they use LOG. Just understood. You can actually punch this if you want. You can also work it out by hand. LOG base 10 and 0.01 is 1 over 100. Well, 100 is 10 squared. 1 over 10 squared. Well, 10 squared can come up, log base 10 of 10 to a negative 2. And now you've got the situation you want where things undo each other. That leaves a negative 2 equals x. And just to double check this one, since they did give this one on the calculator, you can literally punch LOG. And I got to turn the calculator on. Okay, so you can literally punch LOG, if you get the glare off, of 0.01. And there you are, negative 2. Okay, try a couple more here. How about 39? Part A. Base 7 of 1 over 49 equals x. All right. We are doing 4-4 this week, so I can show you how to punch this, but until I hit 4-4, I can't punch it at this moment. Same idea, 49 is a square, it's 7 squared. 1 over 7 squared equals x. This comes up, log base 7 of 7 to a negative 2. And this would also equal negative 2. How about 39b? By the way, these are on page 388. Oh yeah, okay, yeah, we're still on the same page. 39b, log base 2 of x equals 5. All right, we're going to have to raise to power 2. 2 to the log base 2 of x equals 2 to the 5th. Cancel. 2 to the 5th is 32. You can almost see the check here, log base, here's the check. 32, does that equal 5? Well, 32 is 2 to the 5th power. It's almost like going in big circles. And sure enough, those would cancel. 5 equals 5. So it's almost like going in big circles here. You're constantly undoing things. All right, now 45 and 47 are intended to be super easy problems. They're just calculator punches. They give you nothing in 45 and 47, this whole section, but LOG and LN, and those are on your calculator. So, page 388. A, log 2, and they're saying approximate to four places, pretty anal. LOG is base 10 on calculator, and you want, use your, of course, your LOG key. log, log of 2. Golly, log of 2. Okay. 0.3010. In 47A, ln of 5, use your ln key. That's your natural log key with base E. ln then 5. A little bit of delay on this, more delay than usual today. Enter. 1.6094, I guess, to 4 places. I'm not really anal about the rounding. I won't, if I say 3 places and, and each you got 4 away, I'll try to make my true or false problems more obvious than that. I won't try to trick you on something as minor as like places. I say 3 and 4 and that kind of thing. That pretty much covers 4.3. When we went to 4.4, we're looking for 9 to 57 odd. Or 4, 9 to 57 odd. So these are off 4.4. Page 395. More delay on this Wi-Fi this morning than usual. I'm having to slow down and wait for the Wi-Fi to catch up. They're talking about 3 laws of logs. Okay, I hope everybody remembers this again without a whole lot of lecture to it. Should mention them before we charge in. Number 1, say, if you take, I'll use ln of an A and you add, well, they usually present it going forward. If you multiply by a B, so an ln of a product, this is called expanding it. ln of the first plus the ln of the second. If your 2 things are divided, they subtract. Log at the top minus log at the bottom. And the main thing to take away from this is that bottom pieces have negative logs, have negative logs, top pieces have positive logs. Okay, powers, law number 3. An ln of an a to a power. You can put the power in front as a coefficient. I could punch out some of these with numbers. Maybe I should just one of them just to remind everyone. I hope everybody's seen this. For example, law 1. Law 1 here, if I took an ln of 5 times 3, I would get an ln of 5 add an ln of 3. So I can punch the left side as ln of 5, literally 5 times 3, or ln of 15. I'll just do it 5 times 3. And I can go ln of 5 and add ln of 3. So you can sack the same thing, 2.70805. 2.70805. I hope you believe the rest of them. So now you go to the problems, and they are going to use this on these problems. So page, this is again 4.4, page 395. And number 9, say, for the first one. A log of 50 add a log of 200. I want you to evaluate this. Well, the way we wrote it down was we said an ln. You can use ln log, whatever form you want. Of an AB was equal to ln of A add an ln of B. So this is your A, this is your B. You see when they're added, they're put together in one log with the 50 and 200 multiplied. So this would be equal to log 50 times 200. Well, 50 times 200 is 10,000. 10,000. 10,000 is 10 to the 5th. My fault. 4th. God, wake up. My fault. 4th. 10 to the 4th. There's 4 zeros. 1 times 10 to the 4th. The answer should be 4, because these undo each other. Okay, you can check this one directly on the calculator, might as well, just to give you some confidence in it. If I punch log 50 and add log 200, oops, got to watch your parentheses. See how I have left off a parentheses? I'm not going to get the same answer out of this because it's all put in one log. So I got to back up, close that parentheses. All right, now I got to add log 200. Okay. Let's see. Going down to, you can try one like number 19. Log base 4 of a 16 to a 100th power. And there is no log base 4 key. Now you can play this several ways. We can put the 100 in front and then play around, or I can just write 16 as 4 squared raised to the 100th power. When I raise to these powers, they multiply. That would be a log base 4 of 4 to the 200th power, which would be a darn big number. And you can see you should get 200. All right, from 23, the last two sections, you get into some algebra of this. Still on page 395. You can try one like 23. My delay has gotten much shorter, thank goodness. Okay. Again, this is like your A, this is like your B from up here, except that, this is like your A, this is like your B, 8x, so 8 plus log of x. Log base 3 of 8 plus a log base 3 of x. Well, they've made this or cooked this to work out a little bit. That's a log base 3 of 2 to the third plus log base 3 of x. And this is equal to 3 because these undo each other. Log base 3 of x. All right, we'll try one a little more complicated, like say 39. And you've got x cubed, y to the 4th, and you're divided by z to the 6th. I can write this out in all the pieces, and I think I will, and then I can show you how to shorten it up. It's kind of a combination of laws. Actually, you got all 3 laws in here, but you can start with a combination of first and second, meaning start with the log of the top, y to the 4th, minus your log of the bottom. Then these two can bust up, plus log y to the 4th, minus log z to the 6th. And now these powers are ready for law 3. They can come to the front, powers to the front. Three log of x plus 4 log of y minus log 6 log of z. The directions were to expand, and that's how it's done. Now, that's trying to written out, all explain, what you should get. There are people, I've run into them, I hate all that writing. Can't I just do it? Yeah, you can. I call it the poof method. Poof method. Just, write it down. Just remember, top positive logs, bottom negative logs. So if you have log of an x cubed y to the 4th over z to the 6th, all right, well, the top pieces are positive, and the bottom piece is a negative log of z. Sorry about that. Okay, well, your powers are coefficients. So if you know your system, yeah, you can just, kind of instantly write it down without showing a whole lot of work. Now, in the bottom section, they show you how to reverse it. From 49 problems through 57, you're reversing it. show you how to reverse it on this one, then we'll try one of those. So if you want to reverse it again, you form to reverse it. You form one log. Your x, y are positive, they go on top. Your z is negative, it's on bottom. Coefficients are powers. C to the 6. All right, so that's what they have you do starting at problem 49. Log base 4 of 6, add log base 4 of 7. All right, well, you're going to want your 2 back up first. This is called combining. Log base 4 of 6, add log base 4 of 7 squared. Well, they're both positive. That means they'll be both on top. Positive, both top. There's no bottom. There's no negative log. Log base 4 of 6 times 7 squared. Well, you might want to work that out just in case they've cooked this. That's 6 times 7 squared is 6 times 49. Squared. 49 times 6 is 294. Don't think 294 doesn't smell like 4 is going to go. You can write that as 4 to a clean power, so we'll just leave it. How about one with letters, say like 53? 4 log x minus 1/3 log plus 1 twice log of x minus 1. Well, if you want the poof method, notice this is positive, so it's on top. Positive, top. And I really, yeah, and then this was negative, bottom. So I write 1 log, and I put the x on top, multiplied by the x minus 1. The x squared plus 1 goes on bottom. Put it in parentheses because it's going to have a power. The 4 is its power. The 1/3 is its power down here. X squared plus 1, and 2 is its power up there. I hope that wasn't too fast. You can almost see the check. It'd be log of this, add log of that. 4 goes to the front of coefficient, 2 to the front of coefficient of that, and the minus 1/3 log of this. I hope that's not too fast. The very last section is called change of base. This is when you can use calculator on any number base. I'll just show you how it works. You know that if I had a log base 2 of 2 to the 4th, I would get 4. Because these would cancel, and well, that's a log base 2 of 16. Well, this change of base formula says I can punch this as ln of 16, ln of 2. So I can literally write every log is an ln, in other words. And And so I can compute this by going ln of the 16 if I scale it by the ln of what the base is. Just punch it to give you some confidence in it. And divide by ln of 2. 4. So it gives you a pretty easy way of computing some of these. If I look at 59, I had ln of base 2 of 5. I'm sorry, God, too early. It says log base 2 of 5. ln of base 2 makes no sense at all. So I could punch this as an ln of 5. Back to my bigger delay here. If I scale it by the ln of the base of 2. Punch away. ln 5. Divided by ln of 2. .322, we'll call it. It makes sense if I had a log base 2 of 4. That would be a log base 2 of 2 squared, which would be 2. So you can see a log base 2 of 5 is a little bigger than 2. Makes perfect logical sense. At least it does to me. All right, that pretty much covers all of the sections for this week. Hopefully that's enough to get you started. Quiz over these at the end of the week. And there are WebAssign problems also. Once again, all the assignments, if I put them back up here, are right here, mailed to you and posted on D2L. Just email me the % of the WebAssign problems you get right. You'll do the quiz 2 on a Google form for me to grade or record the grade. That's the work for this week. We will have another Zoom session on Friday. I emailed you the link. We'll end this session. Good luck this week.